In today's lesson, we're going to perform function operations and composition. We're going to start off with the operations that we can perform with functions, and as you can see, all of the four basic operations are covered. That includes addition, subtraction, multiplication, as well as division. And we can just perform these like we would before, except now we have a way we can express this in a shorthand using function notation. So let's take a look at this in action. In this first example, we're going to define three functions: f of x, g of x, and h of x. And we're going to perform a number of operations with these functions. So we'll start off with a, which is g of x minus h of x. So now we'll substitute what these are. So g of x we have defined as 2x to the 5/6 power minus negative 7x to the 5/6 power. So in other words, we're just going to be adding these two terms together, leaving us with 9x to the 5/6 power. Now keep in mind we can only add and subtract if the terms are alike. In this case they're both x to the 5/6 power. If there's anything was different about them other than the coefficients, we wouldn't be able to add or subtract them. In B, we're going to be multiplying f of x with g of x. So f of x is 8x, and we're going to multiply that with 2x to the 5/6 power. So since we are multiplying these, this will leave us with 16x. Now because this is x to the first, we can write this as x to the 6/6 power, because remember we're going to add the exponents. So that's going to give me 11/6. So 16x to the 11/6 power. And then I would box that one in like so. Okay, so with division, I'm going to write this one out. So I have f of x divided by g of x. So f of x being 8x divided by g of x, which is 2x to the 5/6 power. Once again, we'll just perform this operation like we've done many times before. Really the only things new is the notation with the functions, and this is going to be x to the 6/6. And remember, we're going to subtract our exponents when we divide, so that's going to be x to the 1/6 power. Okay, so now that we've taken care of this, let's look at a different type of problem where we're going to state the domains of f times g and f divided by g. Well, since I know what f is being 8x, I know that the domain of f is going to be all real numbers. So I'll just say the domain of f is such that x is all real numbers. And but g of x is going to be a little bit different. Remember, this can be rewritten as something different. We can rewrite this as 2 and then x to the 1/6 power to the 5th power, or to this, and then the 6th root of x, 5. Well, we're taking a 6th root, which means that we have an even index. That means that x has to be a 0 or a positive number. In other words, x cannot be negative because there's no number that when you multiply itself any even number of times, that will end up negative. So when we write the domain of G, the domain of G is such that x is such that it's going to be greater than or equal to 0. So now we can address the f times g function. So in this case, this the domain of f is all real numbers, so there's no restriction on here. But g, we're going to have this restriction of, x is greater than or equal to 0. But if we look at the multiplied, product, if you will, 16x to the 11th over 6, well, then the domain of f times g is actually going to be a combination of these two things. It's going to be, so I say domain sub f of g is such that x is, well, again, we got that 6 in the denominator, so x is going to be greater than or equal to 0. So it can't be any negative numbers in there, but 0 is fine. When we do the division, domain of f divided by g, okay, so recall when we divided that, we have 4 and then x to the 1/6 power. We still have that 6 in the denominator, so again, we're going to have that same restriction that we had with multiplication, and nothing new, so it's going to be x is such that x is greater than or equal to 0. Okay, so that would, these two would be our answer to part D. Okay, so now we're going to talk about the composition of functions. It would be written like this. So we have function h of x is equal to what we say g of f of x. So normally we would have x inside the parentheses. That would be our input. But now our input is the output of another function. So the way that this is written, we're going to input. So we work this inside out. So we start on inside, then we work our way out. So first we would look at f. And so the input of f would be x. We just plug in numbers in for x, 1, 2, 3. And then we'd put that into the function f of x. And then we get an output f of x. So this will be our output of f of x. But then that output becomes our input for g. So then we take whatever numbers come out there, and we put that in for g, and then that we would output g, and that's going to give us the range of our composite function. And then here's our domain of f, our range of f, domain of g, and range of g. So let's actually work one out, more than one, so we can see what these look like. So we have two functions defined here, f of x being 6x to the negative 2 and g of x, which is 4x plus 5. When I work this one out, I'm going to be looking at how it's set up. So here I have g of x nested in f of x. So g of x is what we would substitute into the x value of f of x. So normally here I have f of x is equal to 6x to the negative 2. And if it was like, if I had, let's say, f of 4, we would substitute 4 into there. So it's a 6 times 4 to the negative 2. But that's not going to be the case. We're going to be actually substituting the entirety of g of x into there. So I would say that this is equal to 6. Okay, so in place of x, we're going to substitute g. That's going to be 4x x plus 5, and then all of that to the negative 2 power. Now we'll simplify this. So since this is all to the negative 2 power, this part drops into the denominator. So this would equal 6 over 4x plus 5 squared. Okay, in B, now we're going to nest f into g. So this would equal, so we start off with 4. Now in place of x, we put in the value of f of x, which is 6x to the negative 2 power plus 5, like so. Now I'm going to simplify this. So only the x is going to drop into the denominator here. So this is going to be, well, and I'd multiply the 4 here. So I'm going to multiply this as 24, and then x to the negative 2 plus 5, and then 24, and as I said earlier, only the x drops into the denominator because the negative 2 is only on the x squared, and then plus 5, like so. And that would be my simplified expression. Next, we're going to look at g of x. So we're going to take g and then substitute g into itself. You can do that. So g of x equals 4, and then in place of x, we're going to put 4x plus 5 plus 5. So now I'll just distribute my 4. That's going to give me 16x plus 20, and then plus 5, and then that simplifies to 16x plus 25. And that would be my composite function. Okay, so D, we're going to talk about the domain of f of g of x. And when we look at the domain of f, okay, so we know we have an x to the negative 2 power, and that can be rewritten as 6 over x squared. So if I think about my restrictions here, is that first off, x can't be 0. Okay, it needs to be, you know, any number but 0, because you can't divide by 0. It could be negative, it could be positive, but it just can't be 0. And then for g of x, it can be all real numbers. So when I write this out, it's just going to be x is such that it's all real numbers that are positive and negative. And the domain for g is x is such that it's all real numbers. Okay, there's nothing that can be there. But if we're going to do f of g of x, well, let's take a look at that. So the domain of f of g of x, so f and then parentheses g, is such that, okay, so I'm going to refer to our evaluated problem here, and it looks like we can do everything except we can't have a denominator that is 0. So we have to find a number that x cannot be. So since this is 4x plus 5 times 4x plus 5, I just need to find what's going to cause 4x plus 5 to equal 0. In this case, x would equal negative 5/4. So if you substitute negative 5/4 into here, then that's going to be 0, and then you have 0 for the denominator. So we can't have negative 5/4. So the domain, really just based off of what we have there, is x is such that it is all real numbers, but except we're going to say x cannot equal negative 5, negative 5/4. Okay, so everything else though will work. All right, so that's performing function operations and composition.